Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is 2992, number of self-divisible permutations. So basically you're given numbers from 1 to n inclusive of n, and you want to make sure that they all elements in the array, each element follows this current rule, which means that the GCD of the value and the index is equal to 1. If not, then the whole thing can be discarded. So let's go ahead and first come up with the brute force approach, which is just to generate all the permutations. So we know that we have elements from 1 to n. And then we can just check each one of them. So for P and permutations of options using the built-in library. So again, let's set a flag. So for J in range length of P, that permutation, which is just a reordering. So 1, 2, 3, 1, 3, 2, 1 or 2, 1, 3. So if not P of I, GCD of P of I and I plus 1, or j plus 1 in this case, because j, notice that we're going from 1 to the length inclusive. Usually it's not. So in that case, if it's not equal to 1, then we can set the flag to false. If flag is still true at the end, then we can just increment answer, because that's going to be another option. So let's go ahead and run this. Okay, so it's probably going to time out because this is exponential time complexity, although it does work for smaller inputs. So let's find a better way to do this, because if we submit it, you're going to pass 10 out of 12 test cases. So the better way to do this is to prune when we don't need to. So use a backtracking approach. So let's first generate a recursive function, and let's start with 1 and an empty list, and let's call this index and current. So if current is length of n, or the size is equal to n, then let's print current and return, because we don't want anything bigger than n, right? They're all size n. So otherwise, let's go ahead and generate all the permutations using options. So options is still going to be there. And basically, as we iterate from left to right, 1, 2, 3 in order, we're just going to include the actual index plus 1, and then current plus a list of options of I, basically appending options I to the end of current. And so, okay, so let's go ahead and just return a dummy value so you can see that we've generated all the permutations. And you can see that, first of all, we don't want any duplicates. So if options of I is not in current, then we can go ahead and do this. So that saves a little time. So you can see we have all the permutations. But now, instead of checking every single one, why don't we just say if the last element, if current of -1, if the GCD of this one and the actual, so the value and the index, which is just going to be length of current, because remember we did j plus 1, is not equal to 1, then we can just return right away, because we don't have to keep exploring if that path is not valid, right? So otherwise, we can go ahead and increment our answer, because we're reaching n and we're a valid path, and then at the end we can just return self.answer, right? So let's go ahead and run this, submit it. Probably need to get rid of this. Okay, and there you go. Passes all test cases. So again, I'm super happy that I was able to solve this question completely on my own without any help. So that's it for this video, and thank you for watching.